Hi, I'm Mark, software mentor from Team 93. Welcome to our third video in our YouTube series on using WPILib in Java to write robot code. In this particular video, we're going to be talking about the OI and the robot map classes. So first, let's start talking about the OI. The OI stands for the operator interface. And I mentioned in the overview video, the first video in this series, that the OI class is generally the class where you'll create or instantiate the classes related to the teleoperated period, like the joystick class, joystick button classes, and any of the commands that are associated with those buttons. And the way that this works is actually explained pretty well in the template project that's automatically created by the WPILib plugin in VS Code. So if you read through these comments, it explains how when you are trying to create code related to the teleoperated period, generally the first thing you're going to want to do is create a joystick class and then create a button that's associated with the joystick class. Once you have your joystick and your button, then you can start doing some pretty interesting things with the buttons, like, for instance, tying particular commands to the buttons. When I mean, and what I mean by when I say tie a command to a button, I mean that there are certain methods associated with the button class, like when pressed, while held, and so on. And when you call one of these methods on the button class and pass in a command to that method, then, for instance, when you call the when pressed button, what that means is this command that I'm passing into this method will be executed every time this button is pressed. If you call the while held method and pass a command into that method in the parameter list, then while that button is held, then the command will be run and then interrupted when the button is released, and so on. And if you want more information about all of the methods that are available to you in the button class, in the joystick class, and so on, then the WPILib Java docs are a great resource to learn a little bit more about the options that are available to you. But the short story is that the WPILib is very powerful and gives you a lot of flexibility when it comes to tying particular commands to particular buttons. And one of the cool things about this tying a command to a button, as I'm calling it, is that these commands will get automatically run when these conditions are met because of the fact that the scheduler is running. The scheduler is something that we talked briefly about in the previous video when discussing the robot class. The scheduler is run every cycle of the control loop of your robot in these teleop or autonomous periodic methods. So these periodic methods, as we mentioned, run every 20 milliseconds, and every 20 milliseconds, if you have a line like this in your method, then the scheduler is going to be run. If you hover over this run method, you can see exactly what this scheduler run method is doing. And one of the things that it's doing, you can see at the top of the list, is polling the buttons. Polling the buttons just means that it's querying the state of the button to know whether it's pressed or not, and then taking the appropriate action based on the commands that have been tied to those buttons. So that generally covers the OI class. The other class that I want to talk about in this video is the robot map class. And this is, again, a class that we talked about very briefly in the overview video, but I want to just provide a little more detail here. This class is very important because this generally contains the mapping between hardware resources like pins and ports with the subsystem components like your sensors and your speed controllers. So as part of your various subsystems, like for instance, you might have a subsystem called a drivetrain. With a drivetrain subsystem, you're going to have various speed controllers that are controlling the motors that are part of your drivetrain. You might also have various sensors, like for instance, encoders, like a quadrature encoder is a fairly common sensor that you might have and use the encoders or a gyroscope together with your speed controllers to do closed loop control of your drivetrain during your autonomous mode. But all those components that I mentioned, including the speed controller, encoder, gyro, and so on, in order for your software to be able to communicate with the speed controller and write certain values to the speed controller and query, the measurements that are coming from the sensors, then you need to know what pins and ports those hardware peripherals, are associated with. And it's helpful to have that association information in just one place in your code. And the main reason for this is maintainability. If you ever need to change how that hardware association works, because, for instance, maybe your hardware or electrical team on your first team wants to change something, then if anything changes, you don't want to have to find all the different places in your code where that information is stored or used. So generally what teams do is they have all that information in one place, and if it ever changes, you just need to change it in one place, and that change takes effect throughout your entire code base. It makes your code much more maintainable and easier to change, which is very important to be competitive within the first season. You always want to be inspecting and adapting, looking at other teams, seeing what they're doing, trying to figure out whether there's a better strategy that you can employ to be more competitive. But in order to be flexible like that, it's important to make your software easy to change, and this is one of the ways that you can do that. So that's all I really wanted to cover in this video. I really appreciate you watching, and I hope to see you in the next video. Thank you.